Okay, first, before we start, I'd like to apologize if you hear any frozen in the background. That's my way of keeping my daughter from interrupting while I teach this stuff. All right, we're going to learn about the properties of powers and how you use powers and exponents in math. The basic deal is going to be whatever's happening to the base, whatever operation. Here's our 6 basic operations. The powers, the exponents, do one operation below whatever's happening to the base. So if I have a base being raised to multiple powers, I multiply those powers. If I have a base being divided with multiple powers going on, so if base is being divided, I will subtract those powers. And if I have a base being multiplied, this stuff, I add those powers. Big caveat here is if I'm getting ready to add and subtract powers, they have to be like terms. In this case, that means they had to be the same bases. So, for instance, I can't do 3 squared times 4 cubed. I can't add those bases, those powers, because those bases are not the same. Because they have to be like terms in order for me to add and subtract. However, if this was a 3, then they're the same bases. Now I can add those because I have to have the same like terms in order to add those. All right, so let me just run you through a couple basic examples here. I have x squared times x cubed. My bases are the same. They're being multiplied. So I go over multiplication, and I add those powers. Again, are they like terms? Yes, they are both x's, so I can add them. And they'll give me x to the 2 plus 3, which means it's x to the 5th. All right, same thing here. Now I'm dividing bases. Divide. I would subtract powers, as long as they're like terms. Those are both x's, so I can subtract them. That's just x to the 5 minus 2, and 5 minus 2 is the third. All right, another fun example. Now I have a base being raised to multiple powers. Powers multiply, that becomes x to the 3 times 2, which is just x to the 6th. Now, really cool. Now I have base. Each base has a power of 1. If there's no power listed, it's just to the first power. 1 likes to be invisible, right? Now, this 3 to the first power is also being raised to the second power. So powers multiply. I don't have to worry about like terms now. So now I can literally take that as this 3 is going to go up to the second power. 3 to the 1 times 2. And this is also times x to the 1 times 2. So that's just 3 squared, x squared. 3 squared is simply 9, because I can do that. X squared is x squared. Now, also another way of looking at that, if I don't want to see it as a power being raised to a power in different bases, that is a power with multiplication inside it. The weakest operation inside the parentheses is multiplication. And since I have a power and multiplication, I can also just use the distributive property and distribute down one level. So my powers can be distributed to multiplication or division. Just like before when I had multiplication or division, I could distribute it across addition or subtraction. Same idea. Now for the really powerful, cool stuff. X to the 0th power. I can go backwards, right? If I got 0 as a power, I can change that to a subtraction, but no problem. So any two powers that subtract to 0. Let's go 4 and 4. X to the 4 minus 4. That's still x to the 0th, right? X to the 0, 4 minus 4. And I can say, okay, if I was subtracting powers, I must have been dividing my base. My base was x, which means I would have had x to the 4th over x to the 4th. Now, any number that's the same thing on the top and the bottom has to be 1. And in fact, anytime I have 0 as a power, I can do that exact same trick. Any power you want, I'm going to have the same thing on the top and the bottom, which is going to be 1. Really cool, fun property. Anything to the 0th power, except for 0. is going to end up being 1. The only reason why 0 doesn't work is if I had 0 to the 0th power, that would mean I had 0 over 0, and I can't divide by 0. So that's going to be a fun topic in calculus. It's what always ends up happening. Now, that creates a really cool pattern for negatives. Same idea. If I had x to the negative second power, that means I could have had x to the 0 minus 2, right? That's going to give me negative 2 as an answer, which means I would have had x to the 0th. Since I'm subtracting my exponents, that means I was dividing my bases originally, right? This would have simplified to that, which would have simplified to this. X to the 0th, anything to the 0th power is going to be 1 over x squared. And now my exponent is positive. That is going to be a super useful tool. We're going to practice some more of this shortly.